Hi, my name is Amanda McCauley, and this is my Lab 2 presentation. The physics concepts behind this lab were electric fields, electric forces, distributed charges, and lines of charge. The purpose of this lab was to model two positively charged tapes interacting with each other, assuming that the charge is distributed equally along the length of the tape. After attempting to create a charged tape, the initial check was, does the tape interact with your hand? If not, you needed to restart the lab. And it was important, if the tape was attracted to your hand, to touch it as little as possible, because the electrons will move between the hand and tape to make the tape neutral, therefore also making you have to restart the lab. To determine if the tape was positive or negative, I observed how it interacted with a negatively charged plastic pen. And since it was attracted to the pen, the upper tape that I made has a positive charge. And my specific data for the experiment is that I used two pieces of tape that were 8 inches in length, therefore their mass was about 2.2 grams, and the distance when the upper tape began to float was 2.2 centimeters. Using these two identical positively charged tapes, it's possible to determine the excess charge on the upper tape, because at the moment the upper tape first begins to float, the electric force and the gravitational force on the upper tape are equal. But instead of just modeling this as a point charge, modeling it as a line charge with discrete amounts. So the electric field, due to this small piece of the bottom tape on this small piece of upper tape, is shown on this by this red arrow. And you do that for each piece along the bottom to get the electric field contribution. And the net electric field on this point charge dq due to the bottom tape is shown. And then you repeat this process for each discrete point along the top tape. And the sum of all of these E fields is the E net, and then you can multiply that by the charge to get the total electric force. And so here's this system modeled in GlowScript. The green arrows are the electric fields at each discrete piece of the upper tape. The yellow tape is the gravitational force, and the yellow arrow, and the white arrow is the total electric force. And in the code, I varied the Q starting with what I had done in my calculations for if the system was a point charge, and changed the value of Q until these two forces were balanced. And the assumption made doing this is that each tape has about the same charge equally distributed along the length of the tape. So the bulk of the code, ignoring things explained in previous labs and initializing variables, is the double nested loop that goes through the process that I explained in earlier slides of taking one piece of the top tape and going through each piece of the bottom tape and calculating the electric field due to that small piece. So this is an iterative double loop that goes through each top tape and each bottom tape for each top tape. And the comparison between the point charge and the line charge is shown here in the models, and the charges Q are close to the same magnitude. They're both times 10 to the negative 8th coulombs, but the line charge Q was 2.3 times larger, and so the line charge is more accurate and closer to real life, because in real life, charge isn't located at a single point. It's distributed across the surface. And these are different values because we made different assumptions in each case, and due to those assumptions, there's a vast difference in iterative calculations. The point charge only used the E field formula shown in previous slides once versus the one on the right. When my number was 10 discrete amounts, did the same calculation 100 times, so doing it at smaller amounts, it's similar to an integral. It's most likely going to be more accurate to real life.